Hey guys, it's the Junior Coder, and this is part 6 of the Intro to Python tutorial series. So let's get right into it. In this section, I'm going to talk to you guys about comments in Python. We use comments to add notes or comments to our Python programs. For example, here I'm going to make a print statement. So hi there. Now, before that, I can add a comment using a hash sign. And then whatever I type here, it's going to get ignored. It's not going to get executed. Let me show you. So, let's run this program. Look, we only see this message, hi there. So with this comment, we can explain something about our code. We can use them as reminders to fix things or clean things up, or we can use it to communicate with other developers reading our code. These are good use cases for comments. We can also have comments over multiple lines, so we can simply add comments. Each line should start with a new hash sign. Now, one thing you need to avoid when using comments is explaining what the code does. So here's an example of a bad comment. Let me just delete these two lines. And with this comment, I'm going to say print hi there. Why is this a bad comment? Because it's telling me the obvious. It's obvious that the next line is going to print hi there. So use comments to explain whys and hows, not whats. If you have made certain assumptions, you can use comments to explain those assumptions. Or you can use them to add notes to remind yourself or other developers to do something in the code. In this section, I'm going to talk to you guys about classes in Python. Classes are extremely important in programming, and they're not specific to Python. In fact, a lot of other programming languages support classes too. We use classes to define new types. For example, so far you've learned about the basic types in Python, like numbers, strings, and booleans. These are the basic or simple types in Python. You also learned about a couple of complex types, like lists and dictionaries. While these types are extremely useful, they can't always be used to model complex concepts. For example, think of a concept of a point. A point is not a boolean, it's not a list, nor a dictionary. It's a different type of thing. So we can use classes to define real types to model complex concepts. Now in this section, I'm going to show you how to define a new type called point. And this new type is going to have methods for working with points. For example, back to our main program, let's create a list, numbers, 1, 2, 3. You know that here, when we type dot, we can access to the functions or methods available for lists. Now similar to this, we're going to create a new type called point. This point is going to have methods like move, draw, get distance from another point. These are the operations that we can perform on points. So let me show you how to do this. We start by defining a class using the class keyword, and right after that we give our class a name. Now look at the naming convention I've used here. I've capitalized the first letter here. This is what we call Pascal naming convention. So the convention we use for naming our classes is different from the convention we use for naming our functions and variables. For variables and functions, we always use lowercase letters, and we separate multiple words using an underscore. But when naming classes, we don't use an underscore to separate multiple words. Instead, we capitalize the first letter of every word. So in this case, our class only has a single word. If we had multiple words, let's say email client, look, I've capitalized the first letter of every word. Once again, this is called Pascal naming convention, and it comes from the old Pascal language that you might have heard of. So, back to our point class. Here we add a colon, which means we're going to define a block. Now in this block, we can define all the methods or functions that belong to points. For example, we can define a function called move for moving a point. Now note that as soon as we type open parenthesis, PyCharm automatically adds self here. This is a special keyword, and we're going to get back to this shortly. So for now, in this method, let's just print move on the terminal. Now let's define another method like draw. So define draw, And in this method, let's just print draw on the terminal. Now let's remove the indentation. We are done with the definition of our point class, so we need to add 2 line breaks. So with this class, we defined a new type. With this new type, we can create new objects. So an object is an instance of a class. The class basically defines the blueprint or the template for creating objects, and objects are the actual instances based on that blueprint. So we can have tens or hundreds of points on the screen. These are the objects or the instances. So to create an object, we type out the name of our class and then call it like a function. This creates a new object and then returns it. So we can store that object in a variable. Let's call that point1. There you go. Now when we use the dot operator, look, we have these 2 methods that we defined, draw and move. We also have a bunch of other methods that start with 2 underscores. These are called magic methods, and they're more of an advanced topic, so we're not going to be taking a look at them in this series. So now let's call the draw method of our point object and run our program, so you can see draw is printed on the terminal. Now apart from methods, these objects can also have attributes, and these attributes are like variables that belong to a particular object. For example, here, after we define point1, we can set point1.x to 10 and point1.y to 20. Now we can easily print out these attributes. Let's print point1.x and run our program one more time. Take a look. So the x coordinate of point1 is 10. Now we can create another object. Let's call that point2. Once again, we type out the name of our class and call it like a function. Now this object is completely different from the first object. So if we print point2.x, look, we get this attribute error because point2 does not have an attribute called x. So each object is a different instance of our point class. You have learned how to make new types using classes. Now there's a tiny problem in this implementation. We can create a point object without an x or y coordinate. Let me show you. So point, we'll create this object here, and before we set point.x, let's print point.x and run our program. We get this attribute error that you saw in the last tutorial. So point object does not have an attribute called x. This is the problem we have here. It is possible to have a point object without an x or y coordinate. And that doesn't really make sense, because whenever we talk about a point, we need to know where that point is located. To solve this problem, we use a constructor. A constructor is a function that gets called at the time of creating an object. So here on line 9, when creating this point object, we want to pass values for x and y coordinates like 10 and 20. And with this point object that we get here will have its x and y coordinates initialized. So how do we do this? We need to add a special method in this class called constructor. So on the top, we define a new function. Look at the name of this function. Double underscore init double underscore. So init is short for initialize. And this is the method or function that gets called when we create a new point object. Now, when you press enter, Python will automatically add self in parentheses. We're going to come back to this shortly. Now, right after self, we want to add 2 extra parameters, x and y. So let's type out x and y. And then, in the body of this method, we should read the values passed here and use them to initialize our object. So when we pass 10 and 20, these arguments will be used for x and y parameters. Now to initialize our object, we type out code like this: self.x equals x and self.y equals y. What is going on here? This self that you see here is a reference to the current object. So back to line 13, when we create a new point object, self references that object in memory, the same object that we're referencing using this variable. So earlier we typed point.x equals 10. With this code, we set the x attribute to 10. Now what we have in the constructor is exactly the same. We're using self to reference the current object, then we set the x attribute to the x argument passed in this function. So, using this init method, we can initialize our objects, and we refer to this method as a constructor. This method is used to construct or create an object. So, now, let's remove line 14. So we create a point object with these values, and then print point.x. Let's run our program. There you go. X is 10. We can also change these values later. So just before printing point.x, we can set point.x to 11 and then run our program so x is updated. Alright, here's an exercise for you. I want you to define a new type called person. This person object should have a name attribute as well as a talk method. This is a very easy exercise, so you can probably get it done in a couple of minutes. My solution is coming up next. Alright, so first we start with a class keyword. We define this person class. Once again, look at the naming convention I have used here. The first letter of the first word, in this case the only word, is uppercase. Now, in this class, we define all the methods that we need. Currently, we only have one method, that is a talk method. So, define talk. PyCharm automatically adds self. For now, let's just print talk. So this is the body of our person class. We remove the indentation and add 2 line breaks after defining our classes. Now we can create a person object. Let's call that John. We set it to a person. We can call John.talk. Let's run the program. So we get this message, beautiful. But our person object should have a name attribute. It doesn't make sense to have a person without a name. So that is when we use the constructor function. So on the top, we add a new method. The name of this method is $_init_. So we call this method a constructor. Now, in this method, we need to add another parameter that is name. So we simply set self.name to name. Once again, self references the current object, so we're setting the name attribute of the current object to the name argument passed to this method. With this, we can go back to line 9, and when creating the person object, we pass a name, let's say John Smith. Now, let's print john.name and run our program. There you go. So John Smith is printed on the terminal. So this is all you had to do as part of this exercise. But let's try to make this program a little bit more interesting. Instead of printing this boring talk message here, let's print, "Hi, I am John Smith." So we can use a formatted string with a message like, "Hi, I am." Now we want to dynamically add the name of this person. How do we do that? Well, look at the parameter of this talk method. As I told you before, every method in our class should have this parameter. And this should be the very first parameter of every method. So with this self, we can get reference to the current object. So we can add curly braces and type out self.name. This returns the name attribute of the current person object. With this, we can remove line 10 where we print john.name and simply call john.talk. Let's run our program. "Hi, I am John Smith." Now we can create another person object. Let's say Bob is a new person called Bob Smith. Then we say bob.talk and run our program. We get a different message. "Hi, I'm Bob Smith." So each object is a different instance of our person class. In this section, I'm going to talk to you guys about inheritance in Python. Inheritance is a mechanism for reusing code, and once again, it's not limited to Python. Most languages that support classes also support inheritance. So let me show you how it works. Let's say we have this dot class with a simple walk method. In this method, we're simply printing the walk message on the terminal. Now, let's say in a real program, instead of just 1 line of code here, we're going to have 10 lines of code. Now, what if in the future we want to define another class let's say cat, we want to add this walk method there as well. We'll have to repeat all that code in this new class. This is bad because we have repeated or duplicated our code. In programming, we have a principle called DRY, which is short for don't repeat yourself. And here's the reason. Let's say sometime in the future we discover a problem with our walk method. If we have repeated or duplicated this method in many other places, then we'll have to come back and fix that problem in every single place you have duplicated that code. So that's why in programming we should not define something twice. So how can we solve this problem? Well, there are different approaches. One approach, which is easier to understand for beginners, is inheritance. And here is how it works. We define a new class called mammal and move the walk method right there. Then we'll have the dog and the cat classes inherit that method from the mammal class. So on the top we define a new class. Let's call it mammal. Then we need to move the walk method there. So we select it and cut it using Command and X on Mac or Control and X on Windows. Then paste it in the mammal class. Now we want our dog class to inherit that method from the mammal class. So right after the class name, we add parentheses and then type out the name of the parent class. In this case, mammal. That's all we had to do. So with this, the dog class will inherit all the methods defined in the mammal class. Now there's a tiny problem here. If you look at line 9, there is a red underline here. The reason this is happening is because Python doesn't like an empty class. So right now our dog class is empty, it doesn't have any methods. We either need to add methods specific to dogs, or just to make Python happy, we can use the pass statement. And that basically means nothing. We're telling Python interpreter to pass this line. But with this, we won't have an empty class. So the dog class is now inheriting the walk method from the mammal class. We need to apply the same change to the cat class. So we'll have cat inherit from mammal and then use the pass statement. With these changes, we can now create either a dog or a cat object. Let's say dog1. We set it to a dog object. And when we type dot, look, we have the walk method that is defined in the mammal class. We can easily call it. Let's run our program. There you go, we see the walk message on the terminal. So both the dog and the cat class are inheriting every method that is defined in the mammal class. Now here we can add methods specific to dogs. For example, we can define a method called bark and then print bark. Now we don't need the pass statement because we already defined one method in our dog class. So now when we type dog1 dot, look, we have two methods. One is the walk method that we inherited and the bark method that we just defined in the dog class. So these are the basics of inheritance in Python. So that'll be it for part 6. If you learned something, then don't forget to like, share, and subscribe to my channel. Keep a lookout for part 7 of this series. And I'll see you in the next video. Bye.